Welcome back, everyone. Today we are talking about rectangles. A rectangle is a parallelogram. It's a special parallelogram that has 4 right angles. So the properties of parallelograms all apply. So all the opposite sides are parallel and congruent, opposite angles are congruent, consecutive angles are supplementary, the diagonals bisect each other. But also we know that all 4 angles are right angles. So it's a parallelogram with 4 right angles. We also have another theorem. It's called the diagonals of a rectangle theorem. It tells us that if a parallelogram is a rectangle, then its diagonals are congruent. So not only do they bisect each other, but also the entire diagonal will be congruent. Let me show you this in an example problem. It says a rectangular park has 2 walking paths as shown. If PS equals 180 meters, let's label that in our picture, and PR equals 200 meters, find QT. Now, I know that PR must be equal to SQ. I also know that SQ is 2 times QT since the diagonals bisect each other. So, by transitive property, I know that PR is equal to 2 QT. PR is 200, so I can substitute that in. Divide both sides by 2 in order to get QT is 100. So QT is 100 meters. You can double check that just to make sure it looks correct. If this was 100 meters and this half was also 100 meters, since they have to bisect each other, altogether that makes the diagonal 200 meters, which is congruent to the other diagonal. Alright, try the practice problem below. Here are the correct answers. Let's do another example together. Quadrilateral JKLM is a rectangle. The measure of angle KJL is 2x plus 4. Let's label that in our picture. KJL will be this angle here. And the measure of angle JLK, that's this angle, is 7x plus 5. Find x. Now I know that this is a right angle, angle JKL. If I look closely at triangle JKL, I see that it's a right triangle. I know that the acute angles in a right triangle always are complementary. So I know 2x plus 4 plus 7x plus 5 has to add up to 90. Combine your like terms to get 9x plus 9 equals 90. Subtract 9 on both sides, you get 9x equals 81. Divide both sides by 9, and you'll get x equals 9. I want you to try the practice problem shown below. Here's the correct answer. Now let's talk about deciding whether parallelograms are rectangles or not. This is called diagonals of a rectangle theorem converse. So it says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So in order to use this theorem, you have to first know that it's a parallelogram. So you have to show that it's a parallelogram first by using one of the properties that we already learned about. Look at either page 11 or page 13 for a list of those properties. Okay, let's try an example together. It says a community rec center has created an outdoor dodgeball playing field. Looks like fun. To be sure that it meets the ideal playing requirements, they measure the sides of the field and its diagonals. If AB equals 60 feet, BC equals 30 feet, CD is also 60 feet, and AD is 30 feet. It also tells us AC is 67 feet, and BD is also 67 feet. Explain how the rec center can be sure that the playing field is rectangular. So step one, we first have to show it's a parallelogram. How can we show that this is a parallelogram? We know ABCD is a parallelogram because both pairs of opposite sides are congruent. Number two, we can show this is a rectangle using the diagonals of a rectangle theorem converse that we just learned. So we know ABCD is a rectangle. Side note, there's no symbol for rectangle. Okay, so don't try to make one up. But we know it's a rectangle because the diagonals are congruent. So make sure you first show that it's a parallelogram, then you can decide if it's a rectangle. If it's not a parallelogram, it cannot be a rectangle. Okay, try this practice problem. Here's the correct answer. Now let's try one on a coordinate plane. It says quadrilateral PQRS has these vertices. Determine if PQRS is a rectangle using the distance formula. First, we have to decide, is PQRS a parallelogram? Don't forget, you always have to decide if it's a parallelogram first. In order for us to answer that part using distance formula, we need to see, are the opposite sides congruent? So it doesn't tell us that we have to use distance formula for both parts, so you can really do anything you want to show that it's a parallelogram. I'll decide to do it with slope, how about? So let's check the rise over run of each side. So when we check rise over run of PQ, we are looking at how far down we go. So since we're moving down, it's a negative. We're going down 4. And we're going to the right 6. This can reduce to negative 2 over 3 because 4 and 6 both have a common factor of 2. We'll do the same thing to check SR. It's also a slope of down 4 over 6, meaning a slope of negative 2/3. So I know PQ is parallel to SR. I'm going to get these out of the way. Next, I'll check the slopes of SP and RQ. So I need rise over run again. I'm going up 3 over 2, so that gives me a slope of 3 over 2. Same for RQ, I have to go up 3 over 2, so the slope is also 3 over 2. Since both pairs of opposite sides are parallel, I know that it's a parallelogram. So first I'll say PQRS is a parallelogram because both pairs of opposite sides are parallel. Now I can decide whether PQRS is a rectangle or not. This told me to use distance formula. However, even if I just look at these slopes, I see that negative 2/3 and positive 3 over 2 are opposite reciprocals. That means that this is a right angle here. Remember, perpendicular lines have opposite reciprocal slopes. When you multiply those slopes together, you get -1. But let's check it using distance formula since that's what they asked for. We will do that by finding the diagonals. So we'll find the distance from P to R. We can draw a right triangle if we want. That right triangle has the legs of 4 units and 7 units. So PR is equal to the square root of 4 squared plus 7 squared. Now let's do the same thing for SQ. So if I draw that diagonal in, I can create a right triangle out of it. This right triangle has legs of 1 and 8. So I know that SQ is the square root of 1 squared plus 8 squared. These don't match up, so let's go ahead and add them together. 4 squared is 16. So I have 16 plus 7 squared, which is 49. So that gives me 784. Oh, sorry, I multiplied those instead of adding. Let's try that again. It gives us 65. That sounds better. Next, I have 1 squared, which is 1, plus 8 squared is 64. That also gives me the square root of 65. Since PR is equal to SQ, I know that the diagonals are congruent. So this is a rectangle. Because first we decided it's a parallelogram, then we showed that the diagonals were congruent. Okay, on the next page, there's a practice problem for you to complete. Here's the correct answer. Remember, you always have to check whether it's a parallelogram first. It's not, so we can't even say whether it's a rectangle or not. Finally, I want you to reflect on this question. Why are all rectangles parallelograms, but all parallelograms are not rectangles? Please explain in 2 to 3 complete sentences. Tomorrow we will be learning about a new type of parallelogram called a rhombi and also a square. So I look forward to talking to you then. Bye.